Good afternoon. I welcome you all for today's session. Before we start, let me set the context for the today's session and introduce the speaker. So this is a complete session about design engineer role. Okay. So design engineers has an important role in manufacturing industry. Primarily, who would be a solo responsible for any product success. He must have a knowledge on every aspect of manufacturing to develop a right product. He must be a proactive in learning new things and get updated with privileging technologies. CAD knowledge may not be sufficient to become a design engineer. Okay, so in view of to know more, let us understand what a design engineer need to be and his responsibility. We have organized a webinar on design engineer as a successful career path for a fresh engineer. Today we have with us Mr. H.V. Rajashekara, advisor at IMTMA. So it is about him as he has over 20 years of experience in machine design from HMT Limited and 6 years from Johnson Electric Group, Hong Kong as an R&D head was responsible for high precision machining. In addition, he has 7+ years of experience in IMTMA in training domain. Over thousands of fresh engineers has turned out to be a design engineer and working in various manufacturing industries at present under his leadership. He worked as a senior director design institute before his advisor role at IMPMA. So I welcome you all and hope this session will be very interactive. I feel there are many people came here to find the bridge gap to connect with the industry and how to get an opportunity. So make use of this webinar and be more interactive. And whenever it's required, turn on mic and audio both. So until we during session, if anything, you can put it in chat box. Welcome, Rachika sir.
Thanks, Ratan. And once again, let me extend a warm welcome on my behalf for today's session. A very unique title that we have captioned to bring what is a design engineer and his knowledge is supposed to be and his roles and responsibility in any typical manufacturing company. So how this particular career as a design engineer would help him to grow exponentially over a period of next 35 years. That's in your entire career path. So I come with a background of mechanical engineering and as well and work experience of over 30 years on machine design. So I have understood many of the aspects that are required to become a design engineer at number one, and little bit of passion to work in any manufacturing industry as a design engineer is also another aspect, and how an engineer, especially from the area of design, he could grow. So some of the facts that I would like to bring it in front of you for better understanding so that you will be able to take a decision or a call to choose the career path as a design engineer. Okay. So before I go into my presentation, this is my disclaimer. I would have used many videos, pictures, animations, photographs from various products, which may still belongs to the respective manufacturers. They are used only for the purpose of bringing an awareness on the technology front as a training. Should not be used for any commercial product development activities. So this is the one proverb which we have heard since many years. Necessity is the mother of invention. Yeah. What makes us to develop a product? What makes us to come out with an invention in terms of solving the problem? So this is very essential from our mechanical engineering point of view as an engineer. This is what is the base for us to become the true mechanical engineers. This is also the base for us to develop any product as a problem solving tool. So this is, as an engineer, we need to remember necessity is the mother of invention. This is not a new proverb. It's a very old proverb. But how this makes us to take it through the program, before we begin, I want to understand this very much. Then it helps us how design engineer will be the part of this proverb going forward as a career in design engineer. Okay, now I have shown many products, but may not be everything. There are in and around, you could see the products at your domestic, at your institution, at some of the industry, at wherever you go, you find the products which are being designed, manufactured, and developed by a typical engineers like us. They are all somewhere, one or the other, all products were developed based on the necessity. You agree with me, right? There are many automobile products are available, many household products are available, many IT related products are available, many products that in and around that you could see. And all these products are not just born by itself. There are people who have identified the necessity. There are people identifying the necessity. They would have conceptually thinking how the problem can be resolved by providing a product as a solution. So once we decide there is a product which is required to solve the problem or bring a comfort to a human being, then our engineering role starts. Then our engineering science comes into the picture. How can I apply the systematic way of the learnings from engineering perception and put that into a product so that the product works safely, the product works efficiently, the product also works with reliability, and these are the something that we have a little gap in understanding, conceptualizing the idea, bringing that into a product to solve the very specific problem. Now, if you look at every product, now we can identify what was the intended objective or necessity of bringing this product in front of us. I hope everybody can imagine that anything and everything next to you, you find that a product, then you could find out what was the necessity of developing that product. So in that context, as a mechanical engineer, if you look at all these products, we know why these products are developed. One is it's all only for the human comforts. None of them are able to give you any food or anything. It's all only from the point of comforts that is essential for a human being. What happened? This resulted, the need of the product resulted in manufacturing of the product. Once you start thinking of manufacturing the product, that resulted in many employments and many companies that have come up, and that also in turn, it has helped the growth of our country in terms of GDP. But are we sufficient enough? 10 years before, still some products were available. Motorcycle was available, bicycle was available, many products were available, motor cars were available. Were they the same technologies today? Definitely not. Our requirement, need of a human being within the product itself, in terms of the sophistication, in terms of the cost effectiveness, in terms of the technological growth, it is very essential. And that is the reason you could still see that new products are coming in the similar domain with the latest technologies. So now it comes to the manufacturing. What really is involved in manufacturing? For any kind of product that you can say, typically they are all in line same, that involves one, it should be before this, we need to identify the necessity. Once we have identified the necessity, we have to conceptualize a particular concept of solving the problem through a product. Once we have the concept, of course, it is also a part of the design engineering, then the actual product design starts. The birth of the product starts from the design engineering activity. Second, once we have developed, designed a product, and we made the particular manufacturing drawings so that we can convert the material, raw material into the final product, then we involve process engineering that is based on our drawing, our geometry, our tolerances, what is indicated in the drawing, how to manufacture this part from raw material to the final shape, what machines that are involved, what tools are involved, which people are involved, how much time that will be consuming for manufacturing. This is a start of process, maybe a turning, drilling, milling, grinding, threading. So many processes need to be carried out in a systematic way. So this is another activity in the manufacturing domain. Once we have a drawing, once we have a systematic way of manufacturing, then it comes to the production engineering. That means I need to take a raw material, take it to the lathe, turn it to the length, take it to the milling it to the whatever the requirement. That means all this metal cutting activity will happen in the production engineering domain. So now, having said that, the component is made as per the drawing by a manufacturing engineer or a production engineer, then someone has to qualify that. So we have a quality engineering wherein he will compare all the sizes as per the drawing, whether they are compliant or not, whether material is the same or not, whether tolerance is achieved or not. Unless otherwise, the quality engineer does not qualify, the product will not be accepted by the customer. Then after having made all multiple components, for example, if you take a motorbike, you have a, the gearbox, then within the gearbox, you have a number of gears, shafts, bushings, flanges. So many components are there that they have to be put in a systematic way as per the guidelines of the design engineering. So assembly is another important, the process in the manufacturing. Having said we have a product, we have designed, we have manufactured, we have assembled, we have tested, it's working well, then it needs to be sold. We need a bigger market, we need a sales. That means we have to convert that what we have invested on the raw material, what we have invested on the time for manufacturing, all that has to be recovered with a product need to be sold. Unless it is done, we may not be sustainable in the market. Then also, last but not the least, after the sales as well, we have to give a service support for means. This is also working predominantly in the manufacturing domain. There are so many other processes are involved, but I'm not bringing it here. This is the primary, right from the identifying the problem, conceptualizing, designing, process engineering, production engineering, quality engineering, assembly, marketing, service after the sale. That means this is what it is typically being followed in any products which are being manufactured. Now, my focus today would be more on design engineering. So I would like to bring in more insight, what really a design means, how the design evolves, and a designer, what he need to have to become a successful designer. So these are all something that I would like to highlight in for next 35 to 40 minutes. Okay, now what is design engineering? It's a very simple to define. Design is nothing but a creation of a new or a better product. In case I am indicated a machine, it can be replaced with a product. It need not be machine. Every product which is running, which is moving inside, they are all machines, including mixie, washing machine, lathe, earth moving equipment. Wherever you see an equipment which has a rotary and linear motions, they're all called machines. So it's a creation of a new and better machine. That means I have already a machine. The technologies need to be updated with respect to the current prevailing technology. That is also called as a design. For what? For improving the existing one. Ultimately, what I'm going to get, what I need to do so that it is very economical in the cost of production and operation. So this is a simple way of briefing what is all about the design. Now, comes to the design. What do you mean by design? Very simple statement. It is identifying the product concept, bring all scientific principles and technical informations, what we have studied, what is available in and around, and imagination in the description of a machine or a mechanical system. Why? It has to perform the intended specific operations or functions. Now, if there is a description for a designer as well, what is that? He is the man behind applying all the science, what we have studied, for example, physics, mathematics, mechanics, strength of material, thermodynamics, production engineering, all this science has to come in to in a process of development of a useful product. A systematic way of bringing all these principles is nothing but he called as a designer or a design engineer. Now, there are some principles that we bring in here during our design. What is that? Definitely from the academic front, the load converts into different forms, and that has to be addressed very well and define the geometry. In the size, it could be a square, or it could be a rectangle, or it could be a circular one or a cylindrical one. accordingly load, if it is 100 kgs applied on that from the functionality, then what should be the right material and what should be the right geometry. Once we apply this, then we try to do some kind of an analysis. This is what is called a design. If the load is known, the material can be selected or geometry can be selected, vice versa. If hard material, the geometry can be little smaller. If it is a soft material, the geometry need to be little harder. So ultimately, we need to see that how much it can take the load at minimum deflection. Analysis, if one you know, you can identify 2 or 3 other parameters in order to say that this is the safe to use by any public. So comes to the design process. I'll just bring an industry perspective in front of you. It may be a new for everybody. There is a systematic way of adapting the process of design. First, as I said, as already I told you, need, that means identify, necessity. Then synthesize, taking that into a form of what is the best solution, that is conceptualize the whole product, how it is supposed to address that problem. Then analyze the forces. Once we have a machine, once we have a resources for the forces, then absolutely we need to analyze them and see that what can be the best material for that and what can be the best geometry for that. Then accordingly, the design all simple subsystems of the whole product. The products are made out of, let's say, 100 components. For example, even if you take your motorcycle itself, there could be more than 300 to 400 components may be there. All cannot be designed from, together. We need to have a engine itself is a one sub-assembly, transmission itself is another sub-assembly, the entire motorbike frame itself is another sub-assembly. All this independently has to be looked in terms of the force, in terms of the usage, in terms of the ergonomics, in terms of the manufacturability, in terms of assembly point of view as well. And that's what is called. Then finally, there is a little bit of iterations will happen with respect to the material selection and the design of elements within the process of design. Then we have, if required, the design can undergo a small amount of modifications from the point of manufacturing, from the point of cost effectiveness, from the point of assembly, from the point of reliability. So always that is also a possible. After that, we have this detailed design that need to be done. So this entire process happens within the design and development domain or a design engineering. After this, once we have made the detailed drawing, then it goes for manufacturing, that is process planning, process engineering, production engineering, quality engineering, testing engineering, assembly engineering. All this will happen after that. So before we manufacture, we are the designers need to understand the whole workability and cost point of view, material point of view, geometry point of view, manufacturing point of view. That whole thing happens within this group of the process. Okay, now if that is a case, if that is a systematic way of doing, then a design must be, it should meet the functionality. Intended functionality is what? For example, if you take any product, I would still, now I'll not take a motorcycle, I'll take a CNC machine. A CNC machine, I'll take a typical turning center. What is the functionality of that? It has to turn a component to the maximum diameter of so much. It has to turn a maximum length of so much. It can turn an aluminum component. It can turn a, cast iron component. It can turn so many things, These are all functional. It has to do a thread cutting, drilling, boring. These are all functional requirements. So whenever you intend to design a machine, you need to look at what are the functionalities as well. Second one, whether required quality is being built or not. Third, whether this machine is safe for any human being, he can use this machine without any accident, nothing will break, nothing will fracture, nothing will kill the people or harm the people. Then whether this machine or a product can go for how long work without any downtime, without any breakdown, that is called reliability. Then whether my machine is competitive in the market, whether my counter, the manufacturing company, my competitor is manufacturing for a 10 lakhs, I am making at 14 lakhs, whether this is on the cost, whether it is competitive or not, that has to be looked in. There is no point in no customer will come. Whatever you say, it is my 14 lakhs machine is much better than 10 lakhs. If both are doing the same, then they will not come and buy. So we need to look at competitiveness on the technology, competitiveness and the cost wise as and feature wise as well. Then ergonomic is another engineering altogether. Whenever we use any human being uses the product for usage, it has to uh, give a less fatigue for an user or an operator or a motorbike. Now you are driving or you're riding a motorbike, then after 10 kilometers, if you start getting a shoulder pain, then the handle and the seat and positioning your two legs are not appropriate or not designed for ergonomically. So this is the one which is very, very important. Otherwise, your product will fail. And of course, we need to look at manufacturing point of view, selling point of view, and as well as assembly point of view. That means the design is a multidisciplinary endeavor. It has to have everything before it goes for manufacturing. Once it goes for manufacturing, you will not be in a position to change anything. If it is a right, you will get a right product. If something wrong is made, you will get a wrong product. Now, who can design? Who can be a design engineer? Now we know the design, we know the designer, we know the intensity of the product, we know the process, we know the importance. Then who can become a design engineer? So there are multiple skills that are required. One is you must be thorough in engineering basics, and without fundamentals, the product will not be developed. Second one, this is a typical engineering basics you have learned from your institution, 4 years career, but manufacturing drawings standards may not be addressed in the institution to the extent of what industry is being prepared. We have learned certain basics of that, but we need to understand the manufacturing drawing standards. CAD software, and today it is very, very essential. It should be there so that you do not have a drafting board or you don't have anything manual which you can demonstrate the design. Now, while manufacturing or preparing the drawings, GD&T and tolerances is very important. Materials science, very, very important, because we need to choose whether it has to be made by an aluminum, whether it has to be made by the phosphorus bronze, whether it has to be made by mild steel or cast iron or stainless steel. So what for why I have to make this component, for what reason, whether it is reliability point of view or stiffness point of view or manufacturing point of view. We are the people as a design engineer take a call on which material is most suitable. One have taking so much of decision, I must also know something about material science. Then kinematics, to give a different kinds of motions in the machine. Then we should know the conceptual thinking. Then we should know the manufacturing processes. I cannot ignore this. I am not a production engineer. I do not get into the shop floor. I do not know what is turning, what is milling. I cannot say that. As a manufacturer, as a design engineer, you should have a complete exposure of different manufacturing processes and how, what, why. All this is required. Unless you have a knowledge, when you are making a design, when you are creating a drawing, you may not be able to meet the minimum requirements. It is impossible to make any manufacturing, any feature using the machine. There are limitations as well. We have to be very careful. And of course, it is doable. You can understand the processes. Already you studied in your engineering. Here you need to have a shop floor experience. Then we cannot say that electrical and electronics is not my cup of tea. Today, every product is a mechatronics. Every product is built with equally, even in electronics as well, in the controlling part, and electrical as well in terms of the power. Subsystem design. That means we cannot design a whole machine, but you have to design a subsystem. For example, if you take a lathe, I must know how spindle works. I must know how servo motor works. I must know how to design the cam mechanism. These are all something that we need to understand. Then cutting tools, metal cutting always plays an important role in terms of removing excess material. Then what material, why that cutting tool, how it gives me a productivity, how it gives me a cycle time lesser one. These are all something we need to understand. And structural design, this is absolutely a essential knowledge for the designer, because every machine is built with the structure, and every structure will undergo huge amount of forces, different magnitude and different directions. How to sustain that and have a minimum vibration, how to optimize the mass and how to optimize the stiffness is the one which brings in here. I'm just putting at a macro level. There are each topic is need to go much more deeper. That's what is very essential for a designer. Role of a designer, you know that I just put few pictures here. Okay, now I'll go with, first of all, we need to look at the customer interface. That means we always have an opportunity to have a discussion with the customer, understanding what is his requirement. Then I'll go with a conceptual proposal based on the discussion of the requirement of the customer. Then I will get into the product design. Then I will go with if any fixtures are required to develop for manufacturing. Then I'll go with the process in case I need to know how my components are getting manufactured. So I will have an interface with the process department. And of course, I will also need to have an interface with production department. I cannot ignore that, I will not go out of my air-conditioned room or a CAD room, let it happen in the shop floor. Cannot. Your own parts are being manufactured in the shop floor. Definitely, your shop floor operators may not be as equal in terms of the knowledge. You will have to go and clarify some amount of clarification, some tool breakage, something is not possible to assemble, something not possible to hold. All this we need to have an interface with multiple departments. Then again, we need to have a vendor interface. Some of the components we may not be able to buy, manufacture within our shop floor, like bearings. I will not manufacture. I need to have a vendor interface as well. Casting manufacturing, I need to have an interface with casting manufacturer. So our roles as a design engineer, because every part is designed by me, every part geometry that I know, every part manufacturability point of view that I know, unless I pitch in, of course, in a first product development. Subsequent, you don't need to go at all. First product as a prototyping, we need to have an interface with various production interface. Again, one more production interface for different machines. Then quality inspection interface. We'll have to get into the quality department as well. Some tool is not available, measuring tool is not available. How to measure the manufactured component may be a challenge for him. You may have to go and interface with them and advise them how to do it. And finally, we need to have electrical assembly interface as well. That is very important. As I said, we need to have some amount of knowledge on electronics and electrical. Then we need to have mechanical assembly interface as well. Because whatever you give, the different individual parts for manufacturing, based on your design of assembly, then assembly technicians need to understand which part will go first, which part has to be assembled, how bearing need to be assembled, what the lubrication that I need to bring in. These are all something guidelines that we need to go and stand in front of them. That means before manufacturing, I must know how my machine is going to be assembled as well. That means the design for manufacturing, design for assembly is a part of the role of a design engineer as well. Now, testing, you develop the product, you manufacture the product, you assemble the product. Again, we need to go and stand next to them, how to do the testing and qualifying the product, which are meeting the intended design objective of our customer. So that is also part of our knowledge. That I'm not saying that we need to become an expert in those areas. Every area, people are experts, are available, hands-on skill, technicians, engineers are available. But as a pilot product, first, everyone will get a doubt. Everyone will have some kind of a discussion. So we need to collaboratively work with them. Then commissioning. It is not end at our shop floor. Sometimes we'll have to take our machine to the customer place and put the machine in the production, prove the machine which is going to work. So till then, right from identifying our interface with the customer and back to the customer with a solution is the knowledge of a design engineer. Then only he will become a successful design engineer. Okay. Now, if you look at a multiple, what could be the growth over a period of your experience with respect to the position? First, maybe a 1 year, you will be under individual component design. Then maybe next, continuously working with a system or a company, you would be promoted to the level of, I'm not saying from the hierarchy's point of view, as in positioning yourself as a responsibility, then you would be able to take independently a complete subsystem design, drawing, conceptualizing, and everything. Maybe at the 5th year, you'll be able to take the full product as an independently. Then maybe at 10th year, you will have multi-systems or a multi-products responsibility developing concurrently. Maybe at 20th year, I'm just this is how the responsibility, the growth rate in terms of the positioning, the knowledge, based on that, you'll be growing. Multiple projects you would be handling. Then you'll have a chances to become the factory head to lead the entire business as well. Then of course, after 30, 35 years of experience, you will become a lifetime consultant. You are the man required for anywhere with the amount of knowledge that you have. This is the one which we can work like a doctor n number of years until our last breath. This is the beauty of the position or a design engineering career growth. Now, if you look at the financial perspective or a prospects growth perspective, initially it may not be, because first to 5th year, there will be a very gradual increase will happen unless otherwise you are very smart. Then once you have a confident on your 5 years of experience and commanding and all, your demand will rise like anything in the industry. There will be a lateral, you can go to any size of the company, it is an exponential or a rapid growth will happen. But this is the problem for till 3rd year or a 4th year or 5th year, people need to have certain amount of, because these are all first 3-4 years is the learning period for everybody. You will not be able to do a proper justification to the remuneration what you'll be getting in the first, say, a 2nd year or 3rd year, because there will be a huge amount of learning. You learn any amount may not be sufficient at all. So because you have so much of responsibilities as a design engineer. Now, design engineers must know what a single quality can make a manufacturing or a design engineer may not be possible. As I said, there are multiple roles, multiple skills that are required for you people to do that. Should have a high passion, high dedication, good in mathematics and physics, because mechanical engineers and electrical engineers must be good in mathematics and physics, and analytical and problem solving. Whenever you see something, how I can come out with a solution. Why this person, why this machine is facing this problem, why this component is failed. Some kind of the thinking ability is very, very essential. Then of course, communication is also very, very important, in the process of career. Okay, commitment is very essential. That is highly appreciated in manufacturing industry. Now, coming to some of the aspects where we need to be very strong. One is the drafting, CAD tools, part assembly, part modeling, part drawing standards, aware of all graphical languages, including orthographic projections. Why I'm trying to say here, design is one part. In a 3-dimensional, you'll give a diameter, you'll give a slot, you'll give a right selective material, then you'll make a hole. Then everything is done in a 3D. I cannot send the 3D drawing to the manufacturing shop floor, because they cannot understand anything. Every feature has to be given, defined, every feature, every dimension, every controlling the dimension in terms of the tolerance, GD&T, material, surface finish, all this probably we will show you in the last, from the CAD itself, my colleague Mr. Patil will be able to demonstrate that what is all about a manufacturing drawing. We must have a thorough, because this is the one of the universal language, graphical language. Whenever you make the drawing appropriately, you can send it irrespective of any country, whether they speak English or not, they will understand your language intended for manufacturing. Okay, something similar to that. Then we have creative, quantitative, and the transforming ideas, thoughts into a tangible thing. These are all something is not available in any textbook. These are all something, an attitude that we need to develop by ourselves. We need everybody will not come with all these built-in qualities, but this is the one which we can always, wherever we find that I'm unable to think, we can practice that. Wherever I can see that I'm unable to analyze, we can practice that. Only thing is our serious mind will definitely find some route to identify that. If we have a necessity to learn something, and it is you will by somehow you will learn it. That is what is required. Imagination ability. You should be able to visualize how it comes here, how it comes there, what will happen, whether should I use the same gear, whether should I use the pulley, whether should I use a shaft of that material. These are all something that we need to ask plenty of questions within ourselves. Then adaptability. Adaptability is depending on the situation, we need to get into the environment very highly suitable with that. And forecasting ability, these are all something which not learned in any of the textbook or a curriculum. This is something we need to develop ourselves. Then we have a strong in engineering fundamentals. There are 4 years of time that you have spent on this. Now, these subjects were looked in from the point of qualifying from the examination. Now, to be very frank with you, these are the sciences that we are trying to adapt in product development. Strength of material is very important. Mechanics is very important. We don't need to by heart all those formulas what need to be brought in here. If you can imagine a component made out of a steel, if applied a force to carry out certain function, that will undergo certain amount of stress. So but what you have learned as a compressive stress, right? So what happens when the stress is applied? There will be amount of strain. Whether strain is acceptable from the point of reliability, acceptable from the point of working principle, acceptable from the point of any other reason, is the one what I need to look into. This is all simple aspects that need to be looked in your own product. Even today we follow this. Listening capability, good in communication, these are all something, soft skills that again I'm repeating here. Then again, good in manufacturing processes, what are the different types of metal cutting, turning, milling, grinding. A certain amount of knowledge is very essential. And also you should have an experience going close to the machine so that how things are happening. Then what are the different types of machine tools that are available? Metrology, measuring instruments is very, very important. Cutting tools, I'm keep on saying this is required for a design engineer to know at macro level. I'm not a cutting tool expert. I don't need to take a CMM machine to measure the dimension. There are people, but we as a design engineer must know some basics about these aspects. Strong in CAD, of course, everybody is good in this. You're already undergone some amount of training on this. I don't see any challenge here, but this is not the only which can make the people to become a design engineer. Now, having said this, I just put few pictures in front of you. They are all again designed, manufactured, and they are all working. This is a simple manual sewing machine. There is no motor is connected. There is no, the electronics involved in this. It's a purely a mechanical machine. You rotate that wheel, it starts stitching it. That means the power is coming from either by the hand, or you could see at your home, it is by the leg sitting in a chair. And do you think that the motions from the wheel to the needle, how it is getting transformed inside? Very fantastic linkages have been brought there, converting your rotary motion to the multiple motions of the needle so that the stitching happens. This is a completely a mechanical system. Do you think that this is just like that has born? No, identifying the final process of stitching and how do I bring that motion from what, through what kinematics, what material of this is the one which as a design engineer has to think. Now that is a reduced rotating wheel from a man to a motor is connected beautifully. Then again, we have brought so much of intelligence within the system that I want a different kind of a stitching, then I can program it. Definitely, these are all something, an improvement in the technology, right? So that's what is happening. Now, going forward, what will happen that you can imagine yourself. Take another example of a sugarcane juice, motorized, but again, it is a power operated with logics. Such a sophisticated from left to the right. This is the growth of the technology. I'll give a couple of other, the details as well, products. Now, if you take a metal cutting machine, about before electricity, people used to pedal like a sewing machine and turn the component. Now that has become what you could see in your institution shop floor, a turning center or a center lathe, where it is just a power operated, but without any intelligence. Now, what has happened now since last 3 decades, there is a beautiful controlled by computer, the machine has been developed wherein no operator thinking is required, just a program it, you get any profile, any material, any surface finish, any accuracy. But if you take even automobile sector, there is a, the manually cranked and started motor car to the, power operated motor, the self starter, then automated. Then finally, we are looking at in the coming years is autonomous vehicles. Even without driver, a car can move in. Whether it will happen in India or different, but in the globally it is being developed. I am saying that this is not the end. What I have seen 30 years before was not the end. What I am seeing today is also not the end. It keeps on growing. That's where the young engineers with a proactively thinking, innovatively thinking are going to play a very big role in this technological growth area. Now, I just show you simple comparison of a product for the same application in terms of the productivity. Just look at here. This is the one which is what is happening. A bottle is being capped by purely mechanical operator. You could see he is placing a cap, he is placing a bottle, and he is pressing that. The process is happening. The process is very simple. Cap is there. It has to be put into the bottle, the neck. But now this is not very productive. This is all, again, it will become a fatigue to the operator to work for 8 hours or 16 hours. So much of force he has to apply. So what we have done, we have brought a automatic force that can be developed without any human. Just he wants to place, switch on this, and it comes and pushes and caps. Slightly, this is better productive compared to this technology. And also better, simple for an operator to use. But was that sufficient enough for us? No. Now I have brought completely how this entire process can happen without an intervention of an operator. Now the bottle is getting fed. There is an indexer positioning the bottle. The caps are coming, they shoot from the vibratory board, and it is automatically clamping. So this is how the technology is being grown. Now what you're seeing, the productivity is not today's. It is going even millions per day. Now it is happening only hundreds or thousands per day, but you could see the process will not be able to visualize or see as well. Even it is a, the bottle or anything. So this is the level of automation is also happening in the industry. We are trying to replace most of the human intervention in the production processes. We want everything to happen on its own. This is how the industry is looking at. Going forward, this entire shop floor may switch off and production still will be able to get without any human intervention. Now, these are all something different manufacturing processes. I will not spend much time. You're all aware about thread cutting, turning, milling, gear hobbing, grinding, and drilling as well. Okay, now this is a turning center. I will skip it. You know this already in your shop floor, or you can also come to IMTMA to see this beautiful automated lathe which is working efficiently, so much fast. Turning, milling, facing, step turning. These are all something which is happening. How this, we are only keen on using these products, but we are not keen on understanding how the product is going to work. That's where, as a design engineer, will come into the picture. Something here, another important process, the milling which is happening. This is, we are very good in using as a machine, but as a design engineer, I'll look at how this machine going forward. I'll show you the design of a vertical machining center, but there it makes a huge difference for us. Now, manufacturing, now coming back to one of the important aspects that most probably I will not spend much time here. Their party will be able to handle that. Manufacturing drawing plays an important role in today's the product development, because this is the one of the beautiful language that we bring in here between the engineers to engineers communication through the language. Here, if I am the designer, this was my intended design. This was my intended design in 3D. Can I give the same component to the production engineer? Definitely, he will not be able to do that. He will not be able to do anything, because I can understand the shape, but I don't see what is the size, what is the height, what is the hole size, what is the tolerance between these holes. Nothing is given. Now, this is the one of the best way of communication through the graphical language for a manufacturing engineer or a production engineer. It gives orthographic views, and all dimensions are given here, including the tolerances, including the geometric dimensioning and tolerance. These are all, why are we giving is the biggest question mark. That is a big knowledge that we need to acquire. Why have given parallelity? Why have given perpendicularity? With respect to A and B, where are my A? Where is my B? If not given, what is going to happen in the machine assembly? Whether this product is going to fail, whether this product will be useless, or product is going to be inexpensive. All this has to be looked in. That means defining a geometry, defining the size, defining the surface finish, defining the tolerance, defining the GD&T is very, very important in every manufacturing drawing. So this is if I give this drawing to China, if I give this drawing to Russia or the France where they do not speak English, still the technician or an engineer, even though without knowing English, he will be able to interpret the way that I intended here and manufacture, I get the same component. So this is how the drawing is given, and this is how the manufacturing process which happens, which includes raw material, process, production, cutting tools, programming, and machining. Then finally, this is the product which manufactured from soft copy to the hard part. This is made out of a steel. Of course, it is a steel with a certain grade. This is a threaded hole, reamed hole, reamed hole, reamed hole, chamfer. Everything is given here and is being strictly followed. And this is the right component which comes out from the production department. Now, these are all some of the machine design, vertical machining center, an automation XYZ, a turning center. Just I'm showing in the design stage how it looks like, but does it come to the single stage in the single day? It may not be. We need to systematically learn. Hope, Ratan, I'm audible. Anybody from the room?
Yes, sir. Yes, sir. You are audible.
Okay, thanks. Okay, this is a typical unique machining center as designed and developed and manufactured. If I look at here, this looks so good in an aesthetics point of view, and nothing is visible inside how this machine has been built. What are the essential components which are there? Now, if you just remove the covers, even in your shop floor as well, this is how the machine, the components, there are so many components. Base is there, table is there, the side walls are there. This is a cross slide, X slide is there, Z slide is there, Y axis is there. All this are built with more than 300 components, and they are all working collaboratively, and every component needs a design. So before we conceptualize this, we need to set certain amount of the specification. What should be the table size? What should be the traverse speed? What is the length of the travel? What is the power of the motor? What is the stroke of Z axis? What is the size of the component that we can machine? All that has to be mapped before we develop this. That's nothing but specification. Now, further, if you dismount and see, this is the machine, this is the sub-assemblies of a milling unit, this is the sub-assemblies of an X-axis, this is the base. And even if you remove certain amount, even there, you could see lot of components with the multiple geometries. These are all is there any book or anything? Absolutely no. We have only the material, we have only the design capability, we know how to manufacture, we know how to evaluate the forces, whether how much it can take and how much it can withstand and what would be the life of this. So this is how the design, the interesting of the design engineers. So same thing is continued here. Now let us pick up this sub-assembly alone, just for a discussion purpose. You need to understand, now this is the motor, this is the cutter. In between there are inside so many components that are available. One you can see is the housing, this is the motor mounting bracket, this is the back plate, this is the oil, the distributor, this is the coupling, this is the cylinder, and this is the cartridge. So many components are built in. They have their own size, they have their systematic way of manufacturing, and every geometry is designed for specific reason. I'm not scaring you. This is the beauty of a design engineer, to think and come out with a product as a solution. And every part cannot be sent in this form to the manufacturer. These parts we need to look at, prepare a 2D, a drawing which has all the details for manufacturing. Which has all the details of manufacturing. Individual drawings has to be made, and that should be sent to the production. Now, if you look at the base of the machine, it has so much of features here for intended. The coolant has to go in. There is a vertical valves has to be mounted here. There is a tool turret or an ATC has to be mounted. The table has to be mounted, and it should have space for mounting the lubrication. Should have space for mounting something. For leveling, all this is not a solid, this is a hollow as a cast iron, where we have a below lot of ribs and so many things. These are all, when you're designing this, you get so much of passion to do that. If you make it a solid one, it weighs like a more than 500 to 1 ton, 500 kg to 1 ton. It is waste of material. So we need to bring in, how do I remove the metal, make it as light as possible without compromising the strength of the entire base, because whole machine is coming on top of this. And this should take all kinds of loads. So taking that all into account, designing in a way is also a passionate of a design engineer. Now, this is the design. You look at, for fabrication of this or a manufacturing of this, so much complex dimensions, details that has to be provided in the 2 dimensions. So this is the capability or a capacity of a design engineer. It may not be from the day one, but definitely after 3 years or 4 years of experience, you would love to do these kinds of jobs, because you speak to your design. And one of the greatest satisfaction what we have as a design engineer is the moment you design and after 3 months you see the same component in the shop floor, you get a pleasure of, wow, this is my component, this is my design. And even if it starts working satisfactorily, you will have the satisfaction. Even somebody gives a huge amount of money as well. Beyond that, you will have the satisfaction. So this is another component within that machine design, you can see, and this is the drawing for that. It has all details that has to come in, including just a view to understand how the component looks in the drawing. This is a simple turn component which is used in the spindle. And this is a table what was seen there. This is again the drawing. This all has to be created, imagined by a design engineer. That's the beauty of the design engineer. Now look at this another component. How complex is that? We should know how this component, before we design, this has to be a casted, the gravity casting or a sand casting. There are so many ribs are created to create the strength between this wall to this wall. There are holes that are created here. There is a clamping bolts are created here. You can see the small features here. There is a rib. When you clamp this, and this need to be stronger and connected to this. When I clamp this, the amount of clamping force applied here, there's a minimum amount of deflection. This is something which the beauty of the design engineer. Look at another conveyor part. Of course, I will not go much detail. This is the conveyor, simple conveyor, which involves so many components which comes in. All, when you start designing, it may not come everything in your single set of mind. It keeps on evolving from single component to so many components. This may take at least a month to someone to design this. So with all this, I would like to welcome you all for if you really wish to become a design engineer, there is a gap between what you learn in the institution. Of course, that is very essential to become an engineer. But at the same time, you need to have some amount of other industrial best practices in terms of applying the science. So usually that will be learned only if you come to the industry. But the problem what we have now, the knowledge what you are bringing may not be sufficient for all the companies. I'm not saying that every company. There are companies, they hire the fresh engineer, they will train them for 1 or 2 years, then they will become a design engineer or a manufacturing engineer or a production engineer. But in most of the cases, if you do not have an opportunity to get into the manufacturing industry directly from the institution, then you have left with a medium size and and above large size companies. They hire engineers who have a better skill, so that he cannot give you the sufficient time for training you and making you a full-term engineer. So what they are looking as an association, we have about 470 member companies and who are into manufacturing machine tools, and they are looking at can we have the engineers from the institution with a minimum amount of knowledge in terms of the design. Then how we can build them was the thought process came to IMTMA. And as like me, we try to empanel more than 15 industry design experts who have retired and experienced with more than 35 years. all we made them as a empaneled to IMTMA as a trainers, and we came out with a program called machine hands-on training on machine tool design. It can be a general purpose machine or it could be an SPM. So this program has been kept on doing from 2013, when the Design Institute was established in 2013. Since then, we are training the fresh engineers who want to carry or pursue their career in as a design engineer, and we have trained more than 1,000 engineers who are working successfully. So the same program, due to the pandemic, we were unable to do it, and now we scheduled, hoping that end of this month we may come back to the normal situation from the global pandemic, and hopefully we'll be able to bring all the people to this training room and train them, because there are many industries. Since last 6 months we are unable to train this because of the current situation, and industries are waiting for us to train few people and give them for recruitment. That's what we are looking at. So this program is open, and what we are trying to cover in this program is all the skills what I briefed. It should be emphasizing on engineering basics and bringing a knowledge on manufacturing drawing, then understanding the terms of tolerance, GD&T, machine elements, theory of metal cutting. You name whatever we discussed so far, all informations are brought in terms of application from various people who have an expertise knowledge over a year of 30 years. And this is the beauty of this program. And you also going forward in looking forward, if you would like to really see this, this is the drafting standards. We talk about the drawings, orthographic views, standards, dimensioning schemes, views optimization, surface finish, and tolerancing. And what you can learn from the program on limit, fits, and tolerance, Y tolerance, types of tolerance, fundamental deviations, IT grades, ISO tolerance, fits, and surface finish. What do we learn from program? It's on GD&T. Why GD&T? Why geometric dimensioning and tolerancing? What are the different types of GD&Ts? Whether it is a form error, location, orientation, or position, regardless of feature, feature control frame, and application. These are something very essential, because these are the something which born in the design department from a design engineer. I have designed a shaft. I know what should be the GD&T for this. What should be the material for this? What should be the dimension for this? What is the surface finish for this? So this is where, unless we have all this comprehensive knowledge, we will not be able to become a successful designer. So coming to the machine elements, we help to design a shaft, belt drive, gear drive, spring design, key design, bearing, chain drive, etc. And also theory of metal cutting, we have a huge knowledge from the point of, as a designer, what is that I need to understand in the metal cutting zone. Materials, everybody we have studied. We don't require so much of deep depth knowledge. We need a simple, applicable science, what a predominantly used engineering materials in our own domain. And CNC machines and SPMs, definitely we need to understand the construction, the types, the accuracies, the productivity, the construction point of view. That is also the program is emphasized on these areas as well. Electrical and electronics, we also bring a quite amount of knowledge on control systems, on CNC, and basics of electrical. That's nothing but how the current and the voltage and frequency plays an important role, how it is generated, how it is transmitted. When it comes to the machine, how are we controlling in order to have a appropriate power in our machine, appropriate logic in our machine. That is through the switch gears or a servo technology or a PLC technology. Ergonomics is, as I said, important for every product. If you are unable to hold a pen properly, then it is not designed for ergonomics. There are so many products which comes in, either they are compliant to ergonomics, and whether they're safe, which we do not know. Suddenly some the article or some product will burn off, will burst off. So many things will happen if the systematic engineering science is not applied. Design of hydraulics. Hydraulics is another actuator predominantly used in most of the equipments. And we need to understand what is all about hydraulics, how hydraulics is going to help, how to control the oil, how to create a pressure, how to control the flow. Then what are the different, the hydraulic elements that are involved. It could be a direction control valve, it could be the cylinders, or it could be the hoses, it could be connectors, it could be pressure sensors or flow control valves or tank, pump. All this technology which is essential for a designer is also will be known from this program. So finally, it's high time to think and understand the role of a design engineer. So am I competitive to meet the industry expectation? If you feel like it is yes, but not enough in case, please do join us and we make you the right design engineer to grow exponentially as we promised. This is how what we try to bring in front of you from my 35 years of experience. And this is what by and large 90% of the industry is being followed. This is what the definition and roles of a design engineer. A design engineer is a complete engineer who knows right from concept to the commissioning, every activity in depth, who can play a very big role in every domain. He can be also one of the primary aspects of in terms of the product success. And also at the same time, he could be the disaster as well. If inappropriate application of the science in product development will become a huge cost to the company. If I have not conceived the right material, if I have not decided the right geometry, because manufacturing engineer or production engineer may not be aware of why this shaft is so big, why this bolt is so big or so less, why this part is made out of aluminum. He is not worried about it. He will follow your instructions, whatever is given in the drawing. If your concept, your thinking, your information itself is wrong in the drawing, I'll end up getting the wrong product after the manufacturing. So for that, designer will also be responsible for that. I'm saying not only the good, but also there are bad in case if you are not serious about in your domain. In case you have not applied your mind in the domain. In case if you are not thinking the right way, it's not a clerical engineering job. Designer's job is every day, something will change. Every day, something will come new. So we need to update the technology. We need to update our knowledge and we need to update our adoption to the technology. So with all this, I would say that I love design engineering. I love designers, and definitely you will have that, the pleasure of bringing the products with your conceptual thinking, with your wisdom and knowledge what you have. So thank you very much. Let's see if you would like to know something on the context what I have briefed in this room. If you have any doubts, please do let me know. You can unmute your mic. You can ask me without any hesitation. Yes, Kiran Mai is asking. Kiran Mai is asking, sir, do you have training programs for electrical design engineers? Yes, of course we have. You can be in touch with Ratan.
Yeah.
Sir, hello, sir. Does age matters to become a design engineer?
Absolutely no. But at the same time, you should be at the earliest. Young age is better. If you really want to become a design engineer, then before 30, you must get into this room. Otherwise, you'll have a challenge. But a man has an experience from the shop floor, maybe a 5 to 10 years. If you would like to become a design engineer, absolutely it is very good, because you know the challenges in the shop floor. You can bring those knowledge to the design, then your product even it will become much more productive, effective, efficient, and cost effective. But if you are at the age of 50, 55, I'm not sure whether it is really work, but definitely from the point of understanding the technology. Even last program, we had a person who was managing the company at the age of 63, he participated in the program. He was appreciated, but he may not design, but he will definitely control their design team. That's the beauty of the training.
Will we get placement assistance from
Absolutely.
Sandeep?
our companies are looking forward for the people who have trained, and this is not the course where certificate alone will get you the job. This is something beyond that. You need to be very serious in the program, engage in the program, enjoy in the program, and upskill yourself. We are ready to do that. You need to be a dedicated mind in this program for 2 months. Then nobody can stop you to getting into the industry.